G'day guys, so now we're looking at linear equations. Alright, so linear equations come in many different forms in mathematics, but are easy to recognize because the powers on the unknown values, right? Unknown values are our variables like m down here, right? The powers of our unknown values are always 1. So unknown values might be m, x, y, z, and things like that. They're all 1, alright? So these are all 1. If there's no power, they're power 1 because m to the power 1 is just m, or x to the power 1 is just x. Alright. Alright, if you have a variable with a power of 2 or 3, and so on, it is a nonlinear equation. So that's how we recognize our linear equations. They have a power 1 where it's represented m like this one, where there is no power, but really it's a 1. We just don't need to put the 1. Alright, some other linear equations might also be x plus 3 equals 2, or let's go y plus 4 equals 5, m divided by 2 plus 1 equals 3. Alright, so they're all linear equations because the powers are all 1. Right, so we're looking at the process of finding an unknown value, and this is called solving an equation, which is what this video is focusing on. So when solving an equation, there's a few important things you need to know. You need to understand opposite or inverse operations, and these are used to solve the equation. All right. So when solving an equation, opposite or inverse operations are used that the unknown value to be solved is the only term remaining on one side of the equation. All right, so when we had m plus 2 equals 3. When we're solving the equation, what we're trying to do is we're trying to get that variable on its own. So here we'd use inverse operations. So I'm going to give you a little example just so you can see before we move on. So we're trying to get m on its own. So to get m on its own, we need to apply the inverse operations to this positive 2. Now if we look at our table, when we've got a plus, we need to apply the inverse, which is a negative. So we're going to take negative 2, and we do that to both sides. Right, 2 minus negative 2, we're left with m equals 3 minus 2 equals 1. Alright, so m equals 1. As we've got m on its own, we've now solved that linear equation. Alrighty, moving forward, it is a good idea to have this table in your book. So I suggest copying that one in, it's going to be helpful. Okay, let's have a go. So solving a linear equation. Alright, so the question says solve the equation x plus 6 equals 10. Alright. X plus 6 equals 10. There's our linear equation. We want to solve it for x. We're trying to get x on its own, so we need to apply inverse operations. All right, so we've got x plus 6. We want to get x on its own, so we're going to apply the inverse of plus 6. All right, inverse of plus is minus. All right, so we're going to take 6. Whatever we do to one side of the equal sign, we need to do the other. All right, so these ones cancelled out. We're left with x equals 10 minus 6 is 4. Alright, we've got our x on its own, so we have solved that linear equation and we know that x equals 4. Nice. Alrighty, let's have a go at this next one. We've got solve the equation 3y equals 18. Let's write it out. 3y equals 18. Alright, we're trying to get y on its own. Alright, so remember we discussed previously that in between a number and a variable, so a variable y, there's a multiplication. Alright, so please remember that. Alright, looking back at our tables, the inverse of multiplying by 3 is divide by 3. So we're going to divide both sides by 3. 3 divided by 3, we get 1y, alright, but we can just leave that as y, is equal 18 divided by 3 is 6. Alright. So here we've solved the equation and we've found that y is equal to 6. We've got y on its own, so we've solved the equation. Awesome. Alright, here's an extra example. Now, as you can see, we haven't just got a plus or a multiplication now. We've actually got 2 steps. Now, this is where it comes important. Remember, we're using inverse operations. So usually when we're solving an equation or working through our operations, we work through BODMAS, BODMAS, all right? And we work through our operations, all right? When we're doing linear equations, we're unwinding, all right, what's happening. So we want to work in the opposite direction, All right, we're going to start some subtraction and then finish with the brackets. All right, so let's have a look at addition and subtraction. Is there any addition and subtraction? Yes, there is. Remember, we're trying to get x on its own. Here's our addition. Let's go. We're going to do the inverse operation. -2 on both sides. We're left with 2x equals 10 minus 2 is 8. Awesome. Now, we've got multiplication. That's all that's left. So let's divide both sides by 2. That's the inverse of multiplication, is divide. Remember, there was a multiplication in there. 2 divided by 2, we get 1x, or we can just leave that as x equals. And we're dividing this side by 2. Got to do the same side to each side. And we're left with 4. All right, x equals 4. Nice. Couple more steps. Key points is when we're unwinding or solving a linear equation, work through BODMAS in reverse and apply the inverse.